Have you ever seen a guinea pig suddenly leap, twist, and kick in midair for no apparent reason? It's called popcorning, and it's one of the most delightful displays of pure rodent joy. But what exactly is going on in those tiny, adorable bodies and busy brains when they launch into these spontaneous aerial acrobatics? Today, we are diving deep into the hilarious science behind guinea pig popcorning. We'll explore the fascinating neurobiology that orchestrates these jumps, the unique physiology that makes them possible, and why these little furballs simply can't help but popcorn when they're bursting with happiness. First, let's define our star behavior. Popcorning isn't just a simple jump. It's a rapid, often unpredictable sequence of movements where a guinea pig leaps straight up, twists its body, kicks its legs out, and sometimes even shakes its head. It can look like an explosion of energy. This isn't a trained trick. It's a completely natural, involuntary expression. It's like their entire little being is so overwhelmed with positive emotion that it has to physically burst out. Think of it as a pure, unfiltered celebration of happiness. So, what triggers this incredible spectacle? Guinea pigs popcorn when they're happy, excited, and feel safe in their environment. This often happens during playtime, when they get a favorite treat, or when they're socializing with their human companions or other guinea pigs. It's a clear signal of contentment and pure, unadulterated excitement. Unlike a scared jump, a popcorning guinea pig isn't trying to escape. It's expressing overwhelming positive feelings. It's a behavioral happy dance unique to these adorable creatures. Now, let's dive into the fascinating neurobiology behind this joy. At the heart of popcorning is the brain's reward system, and a key player here is dopamine. This incredible neurotransmitter is often called the feel-good chemical. When a guinea pig experiences something positive, like a tasty snack or a gentle head scratch, dopamine is released. This release creates a sensation of pleasure and reinforces the positive experience, essentially telling the brain, "Hey, this is good, let's do more of it." This is the foundation of linking happiness to movement. The primary structures involved in this dopamine-driven reward pathway are the ventral tegmental area, or VTA, and the nucleus accumbens. Think of the VTA as the main factory producing dopamine, and the nucleus accumbens as its central receiving station, acting as a crucial part of the brain's reward circuit. When dopamine floods the nucleus accumbens, it creates that powerful feeling of satisfaction and excitement that we see manifest as popcorning. These areas are buzzing with activity when your guinea pig is at its happiest. So, we have happiness and excitement brewing, powered by dopamine. How does this translate into physical movement? The journey continues to the frontal cortex. While not directly initiating the jump itself, the frontal cortex plays a role in processing these positive emotional inputs and deciding to engage in playful behaviors. It helps integrate the feel-good signals from the reward system with the intention to move and interact, essentially getting the brain ready for some action. It's where the decision to play often starts. Once the frontal cortex and reward system give the green light, the signal races to the motor cortex. This is the brain's primary control center for voluntary movement. When it comes to popcorning, the motor cortex generates the initial electrical impulses that tell the muscles to contract. It's like the conductor of an orchestra, sending out commands to all the different muscle groups in the guinea pig's body, telling the legs to propel upwards, the spine to twist, and the head to bob. Without this command center, no happy hops would happen. But simply sending a command isn't enough for the acrobatic feats of popcorning. That's where the cerebellum comes in. Located at the back of the brain, the cerebellum is the master coordinator of movement, balance, and motor learning. It refines the raw commands from the motor cortex, ensuring the jump is smooth, coordinated, and precise, even if it looks chaotic to us. The cerebellum helps the guinea pig calculate the right amount of force, timing, and posture for each jump, making sure those twists and kicks are executed perfectly. It's the unsung hero of their aerial ballet. Underneath the more conscious parts of the brain lies the brainstem, a critical structure that connects the brain to the spinal cord. It's responsible for many essential, involuntary functions, including coordinating basic movements and reflexes. For popcorning, the brainstem acts as a vital relay station, passing signals between the brain and the body. It also houses ancient reflex pathways that contribute to the rapid, almost automatic nature of the jump. These are deep-seated, primitive responses that are hardwired, making the uncontrollable aspect of popcorning even clearer. Interestingly, popcorning shares some neural pathways with more primal, defensive behaviors, like the startle reflex. You know, that sudden jolt when you hear a loud noise? The startle reflex is a rapid, involuntary full-body contraction often mediated by the brainstem. While popcorning is triggered by positive emotions, the explosive physical movement itself draws upon these same rapid response neural circuits. It's almost like the brain repurposed an ancient danger response into a spontaneous joy response, turning a defensive jolt into a delightful dance. In a similar vein, elements of the popcorning movement can resemble an escape response or a flight or fight reaction. These are also ancient, hardwired survival mechanisms designed for quick evasive action. While a popcorning guinea pig isn't actually trying to escape danger, the speed and explosive power of the jump utilize similar physiological machinery. It's a testament to the efficiency of the nervous system. Take powerful, rapid movement programs and, when triggered by extreme happiness rather than fear, you get a unique, joyous leap rather than a panic bolt for cover. Beyond dopamine, other neurotransmitters play crucial roles in modulating these rapid-fire movements. Serotonin, often associated with mood and well-being, helps regulate the overall emotional state that leads to popcorning. Noradrenaline, on the other hand, is key in arousal and alertness. It helps prepare the body for rapid physical action, essentially adding a burst of energy to the entire system. Together, these chemicals fine-tune the brain's response, making the popcorning action not just a happy event, but an incredibly energetic and responsive one. Now, let's shift from the brain to the body. The physiology of a guinea pig is perfectly suited for popcorning. Their powerful hind legs are absolute springs. These strong, muscular limbs are designed for quick bursts of speed and impressive vertical propulsion. When those motor cortex signals tell the muscles to contract, the hind legs unleash an incredible amount of force, propelling the guinea pig upwards with surprising agility. It's a marvel of biomechanics, turning those little legs into miniature rocket launchers for pure joy. Beyond the legs, a guinea pig's flexible spine is crucial for those mid-air twists and turns. Unlike some animals with rigid spines, guinea pigs possess a vertebral column that allows for a significant range of motion. This flexibility enables them to contort their bodies, arch their backs, and execute those adorable, seemingly random flips and kicks in the air. This combination of powerful hind legs and a supple spine creates the full spectacle of popcorning, a truly dynamic and gymnastic display of happiness that's both hilarious and impressive to watch. Their small, compact body size also plays a significant role in the uncontrollable yet adorable nature of popcorning. Being lightweight allows them to achieve impressive lift with relatively little effort, contributing to the explosive and seemingly effortless nature of their jumps. Their weight is evenly distributed, helping them maintain a surprising amount of control during the chaos, even as they bounce off in unpredictable directions. This compact design makes every leap a high-energy, high-impact celebration. Even though popcorning looks delightfully chaotic, guinea pigs possess an excellent sense of balance, thanks to their inner ear. The vestibular system within the inner ear constantly monitors head position and movement, sending signals to the brain that help maintain equilibrium. This allows them to land relatively gracefully after their airborne antics, even if they sometimes tumble. It's this intricate system that enables them to perform such complex, multi-directional jumps without completely losing their bearings, contributing to the overall adorableness of their happy dance. So, combining all the science, why can't guinea pigs simply choose not to popcorn when they're excited? It comes down to the deep-seated nature of these responses. The powerful dopamine reward pathway, combined with the rapid firing of the motor cortex and the ancient reflex pathways mediated by the brainstem, creates a strong, involuntary impulse. It's not a conscious decision, it's a deeply ingrained, almost automatic reaction to overwhelming joy. Their brains and bodies are so wired for this expressive burst that resisting it would be like trying to hold back a sneeze when you're truly ticklish. And this lack of control is precisely what makes popcorning so incredibly endearing and hilarious. The spontaneous, unpredictable nature of the jumps adds to their charm. One moment your guinea pig is calmly munching, the next they're a tiny, furry acrobat defying gravity, all because they're just so incredibly happy. It's an honest, unfiltered expression of pure delight that connects directly to those deep brain pathways and physical adaptations. We love it precisely because it's so genuine and unexpected. Popcorning is a behavior largely unique to guinea pigs, making them truly special among our small furry friends. It's a vivid illustration of how their specific neurobiology and physiology come together to create such a distinctive and joyful display. From the dopamine-rich reward centers of their brains to the powerful muscles in their hind legs and their flexible spines, every aspect contributes to this endearing phenomenon. It's a wonderful reminder that these little creatures experience profound happiness, and their bodies just can't contain it. So, the next time you see your guinea pig popcorning, you'll know it's not just a random jump. It's a complex, neurophysiological fireworks show of pure joy. It's a beautiful dance between ancient brain pathways, feel-good chemicals, and a body perfectly designed for explosive celebrations. Thanks for joining us on this deep dive into the hilarious, adorable, and utterly scientific world of guinea pig popcorning. If you loved learning about these bouncy bundles of joy, hit that like button, subscribe for more animal science, and let us know in the comments if your guinea pig is a champion popcorner.